Section 4.1 of the grade 9 applied level curriculum, and the topic is what's called proportional reasoning. And you'll see as we go through, we're going to start by working with proportions, which really are just ratios, and that's the lesson of the day. Typically, the way these lessons start is we're going to start with what we call a 3-minute review, and I'm going to trust that you're going to do this properly, okay, because my eyes aren't on you right now. But what I want to see you do at the start of the lesson is take, and I say 3 minutes, to take the questions at the beginning of your handout, and without watching the video, do them yourself. And that's just a little bit of a, get your brain into math. Then I'll take the questions up in the video, so then you can see if you got them correct or not. After that, the rest of the note will follow. So today's video then, today's 3-minute review is just basically using your knowledge of what the heck is that, and I'll tell you after, to answer the following. I'm pretty sure you could do this, 18 divided by 6, all those things. Now here's the key thing, no calculator. So want to know just how well you can divide. Now the term gazinta is sort of a math teachers who think they're funny, because you say, how many times does 6 gazinta 18? Something like that. Goes into. That's supposed to be funny. So what I want you to do now is there's 6 parts to that question, 6 multiple choice, or not multiple choice questions to do, but 6 divides to do, and I want you to do those without your calculator. Please stop the tape, because I want you to do the whole thing. You stop the tape and I'll take those up in just a moment. Okay, I'm going to assume that you did in fact stop the tape as I asked you to, and I'm going to give you the answers to these questions. Of course, you could just check them on your calculator if you wanted to, but 18 divided by 6, how many times does 6 go into 18? The answer is 3, right? Because 3 times 6 equals 18. Similar over here, 28 divided by 7, how many times does 7 gazinta? 28? I don't know if I get the humor. Anyways, 28 divided by 7 is 4. And just to look backwards, 4 times 7 equals 28. Now this too, this is also a divide. Even though it doesn't have a divide symbol, the symbol is just this straight line. That means divide. 32 divided by 8 is 4. Why? 4 times 8 equals 32. And same thing over here. 45 divided by 9 would be 5. And if you went backwards, 5 times 9 equals 45. That's how I know my answer is correct. Okay, I'm going pretty quick, but I'm assuming that you've got these questions done, and this is just a check for you. Over here, 60 divided by 12. How many times does 12 go into 60? This would be a harder one, but it's not that hard because the answer is a nice, easy one to work with, which is 5. And again, 5 times 12 equals 60. And same thing, 48, that's a divide symbol. 48 divided by 6 is 8. And again, why? Because 8 times 6 equals 48. Okay, so hopefully you've checked your answers and you're all good with that, and we're going to move on. So here's our expectation for today, that you're going to be able to use ratios, and this should be review. What is a ratio? Well, a ratio compares quantities measured in the same units, but not always in the same units. Ratios almost always have whole numbers, so we prefer not to see ratios with decimals or any sort of fraction. And usually when we write a ratio, we write it something like this. And I'll just write this down here. You might write a ratio, 1, do you remember seeing this before? The colon to 2. And that's a ratio. Now, truthfully, when it says here, must always have whole numbers, no decimals or fractions, that means a proper ratio wouldn't be 1.3 to 6.2. Usually you would try to figure out, how could I write those in whole numbers instead of decimals? And that's not really the point to this lesson, but that's what that term means here. The other thing you wouldn't expect to see, 1/2 to 3/4. Okay, again, that's what it means by fractions here. So you wouldn't expect to see that. You wouldn't expect to see that, but this is good. That's a good ratio. Okay, one more thing I should say, and I don't want to confuse you with the idea that ratios, a ratio can be written as a fraction. So another one that is a good is 1/2. That's actually a ratio. These two things mean the exact same, 1 to 2 or 1/2. Okay, so these are both ratios. And just to be clear, these are bad. So that's a bad one. We don't like that. We don't want a half to a quarter, and we don't want decimals. Not to say that you'll never see it, but they're not the best. Should be like this. And specifically in our lessons like this. Okay, so if we want to give a ratio for shaded to unshaded parts here, basically you just count them up. You got 2, 4, 6. 6 is shaded, so I could say 6, and then 2, and then to unshaded, 1, 2, 6 to 2. Okay. Let's see. Girls to boys in our classroom. Well, I guess we need to know how many girls and how many boys in our class. Let's take a look at our seating plan. Put it up here and see how many girls and how many boys in our class. There we go. So if we count them up, let's count the girls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 girls and how many boys? 10 girls and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 10 to 14. Okay, let's go back to our note here. So I'll write girls to boys in our classroom. 10 girls to 14 boys. Now, if we're going to give equivalent ratios, there's different ways you could do that. An easy equivalent ratio means it's the same. By the way, when it says equivalent, it means it has the same. It looks the same. So one way I could do that in a case like this, where they're both even numbers, you could divide both sides by 2. And so if I divided that by 2, it would end up being 3 to 1. And if I was going to draw that, kind of get the same idea, I'm just going to draw so 3 to 1 would look like this, where these are shaded, 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 unshaded. And so what this is saying essentially is it's the same amount, right? It's maybe not the same amount, it's the same percent, 3/4 of it, right? Is filled. So even though, it's not really the same number, this is obviously 8 boxes total, this is 4 boxes total, but it's the same ratio. Another way you could do, so this is a way of getting lowest terms, find a number that divides into both. Another equivalent ratio might be, another easy one is just divide multiply both sides by 2. And you could say 12 to 4. They all mean the same thing. I could keep going. I could say multiply both sides by 3 and say 18 to 6. These are all equivalent ratios. I could keep going forever. Okay? Coming down here, girls to boys in our class, 10 to 14. Similar as the last one, because they're both even numbers, I know I can divide both sides by 2, so one equivalent ratio could be 5 to 7. And that would be the lowest terms, because I can't divide by anything else. Another one would be multiply both sides by 2, and say 20 to 28. Okay? Again, I can multiply both sides by 3, and say 30, you have to figure out 14 times 3, 28, 42, and so on and so forth. You could pick anything that's really a multiple, anything that's a multiple of this, actually, would be an equivalent ratio. So you can either divide each side by the same number or multiply both sides by the same number to find different equivalent ratios. And this one specifically is what we call lowest terms. And the reason it's lowest terms is I can't divide anymore and get an even number or a whole number. And so here we are, talking specifically about lowest terms. And so the idea is to find the biggest number that divides evenly into each side. And that's the greatest common factor, right? So, looking at this one, 4 to 10, what could divide evenly? Well, 2 does, right? Because 2 goes into 4 twice and goes into 10 to get you 5. I don't think there's another number that goes into both sides evenly. So 2 goes into 4 twice, 2 goes into 10 5 times, and that would be my lowest terms. Again, if I tried to go any further, I couldn't. There's nothing, because nothing else goes into 5. It's a prime number. Now here's an example of something I hadn't showed you yet, which is 3 terms in a ratio, and you can still have that. An example where you might see that would be, in some sort of recipe, for example, right? And maybe parts flour, parts whole wheat flour, parts cake flour, and parts sugar, or something like that. It might be a 6 to 3 to 18 ratio, and then depending on how many servings you're making, right? That's an example where you might use it. But either way, you treat it the exact same. I have to find the biggest number that goes into all 3 of these. And if you look at it, what number could go into here, here, and here? Well, the one that comes to my mind is 3. 3 goes into 3 once, goes into 6, and it goes into 18. So it goes into 6 twice, so I'm going to write a 2 right here. It goes into 3 once, and 3 goes into 18 6 times. So I found the biggest number that divides evenly, right? GCF equals 3. And then I went ahead and I divided. And here I guess I should have gone GCF was 2. Now here's a whole different story. Here, I went and told you earlier you couldn't have decimals, and you still shouldn't have decimals. You should not have decimals. You should have whole numbers. So if I want to find lowest terms, first of all, I've got to get rid of this decimal. And the way to get rid of a decimal is multiply by 10, because it's 0 point, so multiply both sides by 10. So I'm going to go times 10 here, and go times 10 here. I'm going to get rid of that decimal, okay? Because decimals are bad in ratios. They're not supposed to be there. So 0.7 times 10, you basically move the 7 over, but you could put that in your calculator if you wanted, but you end up with 7 here, and 6 times 10 is 60. So before I even try to find the lowest terms, I got to get rid of that decimal, is the most important thing. And again, the way to do that is multiply both sides by 10. Now, if I want to find lowest terms, find the biggest number that goes into 7 and 60. And you can think, and the fact is that there's nothing, because 7 doesn't go evenly into 60, and 7 is a prime number, so nothing goes into 7. So we're pretty much stuck. So that's the end. That's the done that. Okay, here I have listed the questions that I want you to work on. So you can get your textbook out, just get a piece of paper, and I want you to do these 4 questions for me. And before the end of class, I will get you to submit a frequently asked question. I'll get you to submit one question that's similar to show me how well you understand it.